Okay, so today we'll see the examples of the master sections. So here, this is the one part we have. So we have a classes surface and this line section we have master section. Okay, so we'll see how to create the solid part using this section. So in this case, here as we discussed in the last session. So in the master section means we are getting the end condition. Okay, so this is the end condition of the part we are going to create and we'll follow the section. So there are two types of section you can get. Either you can get the section like half this. You can see here it is ending, right? So here section is ending at half means whatever the changes we are going to do or we are going to apply here, it will apply everywhere. Okay, from all the sides. Okay, or specifically they want this condition separate and this condition separate, then they, here section will be different. For example, here they want 15 mm and here they want 20 mm length, then separate section will be given. If separate section is not given means, or same for this side also same other condition they want, they will give you the separate section. But here only one section is there and it is we are going to apply all the modifications from all the sides. Okay, so separate section means if you go here, you can see here there are two conditions separate, right? This is one condition at this area and this is one condition. Why? Because values are different, requirement is different. This length of the surface requirement is 5 mm and this length of the surface is requirement is 2 mm. So here difference means values are different, right? Means condition they want different. So they will give you the complete section. Here you can see section is complete, right? Not half. They want this condition from all the side, they will cut the section here. Or you are also creating the section, we need to follow the same. Okay, we are not creating the complete section. Okay, so this is the first difference you need to understand. Now we'll follow the section, we'll create the part. Okay, so this is the input. So I'll copy this. Okay, and we'll go to the standard tree structure here, and the standard tree structure will paste it. Okay, and now here I'll reorder this. So all the rules you can follow the same and we'll keep at the top of the input. Okay. So here, if you see, this is a classes surface and this is a master section. Okay. So classes surface will copy, hide it and we'll paste here. Okay. And then into the surface A, find this and we are going to disassemble this because all the rules will be same. Okay. And then we'll join this. Okay, select one surface with 0.01, right click distance propagation. Okay, with check tangency preview, click OK, select this and select the boundary. Okay, so you can see it is highlighting only outer boundary. It is highlighting only outer boundary. Okay, so this is the surface we have. Okay, so here to create a tooling direction, this part tooling direction is also required, right? The tooling direction, you can see if you keep these views like this, so this complete all the surfaces are visible. So you can use the normal to surface method directly here to create this. Okay, so define this. Then you can create a center of this point using the inertia. Okay, create geometry, CG point, click OK, click OK. Okay, then we'll create a line here, point and direction. Okay, point is this and direction will be, oh sorry, normal to surface we want, right? So line will take normal to surface, right click, multi extraction. This is a big patch, I'll select, click OK and select the point. Okay, so here I'll add the value. Okay, so this is my tooling direction. Okay, so I'll check the draft analysis. So you can change the metal mode now. Okay, and here draft analysis will select. and at 3 degree we'll check. Okay, and select this and reverse. You can see complete surface is clearing. Okay, so this tooling direction is okay, no problem. Okay, and then hide this. So now quickly you can check this all the things. Okay, next is here our section. So this is my section. Okay, so when you receive the section, first check the section. Check the section means here take a plane and take a 3 point option through 3 points. Okay, and select any 3 points onto the section. Okay, 1, 2, and 3. So you can get a parallel plane to the section. Okay, and now you can create a take a cut section. Okay, so in this view, if you see, you can you can analyze the surface here. Analyze the surface means here you can see your bottom line is following the classy surface, right? Bottom line is following the classy surface till here also, till here, till this point. Then here surface is not there, line is continuing, means master section is there till here, right? But no surface. So this surface we are going to generate from in the class surface. Then next is offset surface. So this is the offset, this is the offset. This all the offsets means B surfaces. And this line is belongs to the C surface, which is joining the class A and class B. Okay. That we are going to follow the same. First we'll create a class A surface. So in the A surface modifications, this patch we want to create, right? So this patch means first I need a length. And when you are working onto the master section, don't use the extract command. Okay, we are not going to use the extract command. We want the parametric model. Okay, this I can extract and I can use, right? So that is not allowed. Okay, so you need to create using the other commands. So first I'll check the length. So this is 10 mm. Okay, so 10 mm length surface required. Then angle also will check from this any geometry, any geometry. This to this. This is 128.546. Copy this angle. And then here we'll create a boundary because complete required, right? This edge. Okay. And we'll use the sweep command. Okay. And in the sweep command, we'll use the line type. And in the line type with reference surface command we'll use. Okay. So guide curve is this. Then reference surface is this. Then angle is paste. And length is 10 mm. And check the arrow direction. This arrow direction we want. So select the arrow direction. You can see completely surface is created from all the sides. So if you see this, this is matching now to the master section exactly. Okay. So here if you are using the extract command and then you are creating the surface, then problem is in future I want to change the length of this. I can change, right? I want 15 mm, I'll just change the value. Automatically it will change. But with the extract command that it's not possible to change the value. Only extract means that is a dump element, right? So that's why extract is not allowed. Okay, we want editable things, everything editable. So now your classes surface is complete, right? So I'll join this and this with 0.01. Okay, preview, click OK. Okay, and then we'll give the color. Okay, so this is our first classes surface is completed as per the section, master section. Okay, now next is class B generation. So for class B generation, offset value required, right? So offset value will check. So always you can check with the point to point value. So it can give you the better means exact value 2.5. Here no point to point, so then you can check the lineups. It is 2.5. This to this, there is a different value, right? This is a 1.5. And here also 1.5. Okay, so 1.5, this 1.5 and this is 2.5. So different thicknesses required, right? So we'll go to the B surface offset of 2.5. And first I'll offset by 2.5. Right click. Here you can use the extraction because we want this patch, right? So select this, click OK. Because offset is editable here. Multi-extract is a sub command. Okay, you want to change the offset value, just double click and change the value. Okay, then here this patch is a 1.5, right? So we can use the 1.5 here. Okay, so here surface B offset 1.5 m. Okay, and now define this. Okay, offset 1.5, right click, create multi extraction. Okay, and then select this. Okay, click OK, and 1.5. Okay, same I'll do for these patches. Offset, right click, create multi extraction. These patches will select. Okay, now if I click cut the section, now you can see this is matching 2.5 till here. Then this is also 1.5 matching, and this is also 1.5 matching, right? So now single V surface required. So we need a merging here, right? So merging means extrapolate this time, curvature. Okay, select this. 5 mm is sufficient from all the sides. Okay, same extrapolation for tangent cut. Okay, so now here I can use the trim command, right? So trim this extra surfaces, this side and this side. So other side will be removed. Okay, so now exactly what we want, that we are getting here. Okay, here. Now here the problem is we have a surface till this point it is matching, right? Then it is going into the this radius. Okay, so how much the radius, that we are going to check. So this radius value is around 10 mm, right? So 10 mm radius surface we are going to create. Okay, so first create a boundary of this, then use the parallel curve option. Okay, so curve with this, support it this, and point it this. Okay, and then we are going to split this extra surface. Select this and use the split command. Okay, so now our condition is exactly matching till this, and now we are going to create a radius here. To create a radius, once command we are going to use from the circle type. So use the sweep command, then go to the circle type and select the limit curve and tangency surface. Okay, so here limit is this, and tangency means this limit is attached to this, so tangency. Radius required 10 mm. Okay, and then if you click on the preview, we are getting two solutions. So we want this solution. So select that solution and click OK. Okay, so now you can get a tangent surface from the limit curve, which is exactly matching. Okay, so this is also fine. So now I'll join this both, this patch and this patch with 0.01. Okay, and now we'll merge this. So extrapolation required here also, right? So I'll extrapolate this from all the sides. And now we'll use the trim command here. This patch and this patch. Okay. And the radius requirement is 0.5. Okay. So 0.5 radius we are going to apply there. Select this. .5. Okay. If I cut the section, you can see it is matching, right? Completely. Means our base surface is complete, right? As per the section. So I'll give the color here. Okay. Now next is C surface creation. So C surface always we are creating from the A surface, right? A surface edge. So how much the angle from this to this? It is 89 degree, means 1 degree draft is already given into the section. Okay. So we are not going to apply any draft here specifically. If zero draft, then we can consider our draft. So here I'll create a boundary of this and then we'll use the sweep command now. Sweep command with draft direction or with reference surface, anything you can select. With draft direction, in this case guide curve is this, then draft direction is this, and then angle is 89 or 0 degree you can put. Draft is 1 degree, right, in this direction. 89 means 89 is 1 degree draft, right? 90 minus 1. So here you can put the 1 degree there. Okay. And which side arrow direction? Select 10 degree first. You can select the arrow direction, this side or this side. Okay. First I'll select inside 1 degree. Length will be 5 mm is sufficient. Okay. This will go into the C surface. Change geometrical set to the C surface operations. Okay. And now cut the section and check if it is matching or not. Otherwise, arrow direction will. Now it is matching. If it is not matching, just change the arrow direction. Okay. Here. Just change the arrow direction here. Directly select this or here also next you can select. Okay. Like this. Previous. So if it is matching, then I'll use the split command now. Right. Or first I'll check a intersection. Intersection of B and C. So we are getting one intersection line because B surface is little extra here. So I'm going to cut that. Okay. So in the C surface operations, first we'll split the C surface. Okay. And in the B surface operation or offset, we'll split the B surface. Okay. Done. Now we can join all the three. Okay. So you can create join 1, join 2, join 3 and sorry, join A, join B and join C. Join A, join B and join C 0.01. Okay. And select this and select the boundary. This error is popping up means we can create a solid, right? So at the end, we are going to present the solid model. Okay. So here you can recheck the section also properly. It is matching. Okay. A, B, C side, all the sides. Now we'll turn this part into the solid. So we'll go to this part design. Okay. And then insert a body, properties, close body. Okay. And then select the close surface command. Close surface, same process. Click OK, hide. Okay. Now if I cut the section, so you can see here, if I zoom it, it is exactly matching by solid. And now you can run the draft analysis for parting line generation. right? So for parting line generation, select, okay, select this. Okay. So you can see here cavity side is clear. This is the cavity side, right? But if I reverse the this is showing red. C surface is not clearing. Why? Because we are checking with the 3 degree, and here angle created is 1 degree. So requirement for the core side is 0.5 degree is sufficient. Okay. So now you can see it is turning green, right? So cavity side 3 degree you can clear, and core side 0.5 degree C and B you can clear. So parting line will come at this edge. Okay, so you can extract that complete edge, that will be your parting line. Okay, so like this is a simple part you can solve.